So today we would discuss with you one more concept of organization of distributed software systems. This method organization is called peer-to-peer systems, and it is quite different from the methods of organizations of distributed systems that we discussed previously. All our previous discussions was about client-server technologies and how to organize the client's communication with the servers. But peer-to-peer systems are quite different. In peer-to-peer systems, every node of the network is a client and a server. So without further ado, let's go to the presentation. Some lyrical introduction to peer-to-peer system. This is quite novel concept comparing to the standard client-server technologies concept. And one of the first introduction of this concept was the implementation of the Napster platform that was developed by the student of Northeastern University in Massachusetts, USA, in 1999. Sean Fanning created Napster platform to organize the distribution of audio files between the users of the global network. He thought that it is not very convenient to connect to one server and try to use the resources of only one computer when you can share files between each other. So starting from 1999, he started the peer-to-peer revolution of the network. Previously, in 1997, one of the key aspects why MP3 files started to become so famous, it is because Justin Frankel wrote Winamp. The Winamp platform, the Winamp player, allowed people to easily listen for MP3 files with a very, very nice interface. And 3 years later, in the year 2000, Justin Frankel created GNU-Tella. It is also a peer-to-peer platform that used decentralized search concept to provide wider capabilities for sustaining forcibility of the closure, because just the Napster platform, when it was opened in 1999, it worked only for 1.5 years. In 1.5 years, the lawyers came to the Napster servers and they said, okay, you are not allowed to implement what you created. And they closed Napster. The Napster system was the system with the centralized search index. And as I told you previously on our first lecture, centralized search index, when we have several clients in our peer-to-peer network and they all connect to this index to get the information about who have what files, what sources, what resources they have on their computer. And if a user would like to understand where can he go to find some resources, he sends the query to the index server, and the index server provides him with the IP address of the user who have these resources. So these clients can connect together and start sharing the data. I would describe this concept in the lecture afterwards. But here you can see that if lawyers come or something is going on with the central index, all system becomes unusable because you cannot search. There is no way to search. So Justin Frankel, he implemented another approach, the Gnutella approach. And in this approach, peers that are located in the network do not have any central index. So they have implemented a very direct search protocol. When you want to find something in the network, you ask your neighbors, and if they don't have this, they ask their neighbors. And when someone says, okay, I have this information, then he connects to you and you start sharing data. I will also describe this protocol afterwards. So you can see that peer-to-peer systems appeared in the early 2000s, but today they are responsible for a huge percentage of data transfer in the global network. So let's go and discuss what is peer-to-peer and how is it compared to the client-server technology. So if we take the Intel peer-to-peer working group definition, a peer-to-peer system is the sharing of computer resources and services by direct exchange between systems. So nodes in the peer-to-peer system, they resort to other nodes on the network to search for information, obtain computing resources, transfer files, and etc. And if we go further about how peer-to-peer systems can be described, it is a system that have an operational computer of server quality. So each of the nodes is a client and a server in this peer-to-peer system. Peer-to-peer systems, they have addressing system independent of domain name service because it is overlay over standard network, and they are able to cope with variable connectivity. So peer-to-peer systems are by their design created to have huge amount of nodes that are connecting to each other. On this slide, we can see the comparison between the client-server technology and peer-to-peer architecture. So what does this picture means? For example, we want our client A send some information to our client B. In the client-server technologies, the only way they can do this is to send their file on the server S, and the client B should also connect to this server S and request for this file. And after this request, it can be downloaded from the server S. So all the connection in the client-server technologies is organized through the server that is located and working constantly connected to the internet. There is no direct connection between computer A and computer B. In peer-to-peer application, we have this is a computer A and this is a computer B, and they also want to share a file. But in this case, they do not need this server that is working as middleware for their communication. They create a direct pipe of the communication and they share the file directly between them without the need of separate server. And all the elements of the peer-to-peer network, they can work as a client and as a server. And if you need to connect to some server, you can do it through some client, but you establish the direct connection afterwards, and you share the file or some services or some resources between them. So just a second. This is client server technologies, yes, and peer-to-peer technologies. So if we take a look about the principles of organization of peer-to-peer and client-server systems, we can have some separation between them in the principles of organization. Of course, as everything in the distributed systems world, there is no hard and direct distinguish. You cannot just separate client server and peer-to-peer like this or like this. They merge somewhere in between, but we can distinguish some specific ways of organizations of these systems. For example, client-server technology, mostly when you create client-server system, you can manage the organization of your server side somehow. You create, either it is managed manually by hand, so you say, okay, I install this server here, and this is the name of my server. I install my second server here, and this is the name of my second server. Or you can create a specific automation for deployment of your servers, but it would be also managed by you, by the manager of the network. In peer-to-peer system, by comparison, there is no way you can directly manage the deployment and configuration of your peer-to-peer nodes. Each of the nodes in the peer-to-peer system, it works as a separate unit. It is installed separately by a separate person, and it is not managed whatsoever. It is self-organizing network. In the client-server technology, you can use a direct search, index search to search for the resources. In peer-to-peer network, you need to emphasize a specific mechanism for the creation of research indexes and resource discoverability. In client-server systems, we try to stick to hierarchy of our elements in the network. So if we have, for example, three-layered client-server application, so we have a hierarchy here, yes. We have our clients, a lot of clients. We have application servers. Okay. We have application servers that handle our connections. And the amount of application servers, it is much less the amount of the clients. And we have a database server here. And the database server, amount of database servers is also less than the amount of the application servers. So here we have an hierarchy when the clients are connected to a smaller amount of servers of the first layer, and the servers of the first layer connect to even smaller amount of servers of the second layer. This is hierarchical structure. And this is what we using in the client-server approach. In the peer-to-peer system, we do not create such hierarchies. In peer-to-peer system, our nodes are equal, they are peers. So who would become the first layer, who would become the second layer? It is not possible to organize the hierarchical approach. So in peer-to-peer systems, we mostly use the mesh approach when our nodes are connected like peers and they create a mesh of connected nodes who can share resources and services. Client-server technologies, they are managing static amount of resources. Of course, if you use cloud computing, then you can scale your resources. And when you have two nodes, you can additionally add some additional nodes to them when you have a high load. But this is also managed manually. And the scalability here is not so crucial as in the peer-to-peer systems, because in peer-to-peer systems, each of the resources and each of the nodes inside the network, it is temporary. So each node of the network can go inside the network at any time, can go outside of the network in any time. So the structure of the network should be responsible for organization of good connection and resource usage of such resources. Client-server technologies depend on the server lifetime. In the client-server technology, all the clients, when they connect to the server and the server fails, the system would be broken and you would not be able to achieve any resources. In this case, if the server fails, nothing works. In peer-to-peer system, that is different. In peer-to-peer system, if you have a lot of peers and they are connected to each other, and there is no server that can break all the system. For example, okay, this node failed. So what's the problem? These two nodes would organize their new connection directly. These two nodes would organize their new connection directly. And these two nodes also would organize their new connection directly. So the nature of peer-to-peer system is very, very reliable connection. And it can live through very, very big changes in the network. And also, as I told on the previous slide, client-server technologies, they rely on DNS for naming of their clients and servers. And peer-to-peer systems, they use different independent naming methods. And also, when we talk about client-server technologies, we can say that we mostly use synchronous communications. Of course, we can use message queues to organize asynchronous communications, but in peer-to-peer networks, asynchronous calls, it is the way to organize a connection because synchronous connections are very hard to establish. So what are the problems that client-server technologies have that peer-to-peer systems try to solve? I'm correcting my slides on the go. Client-server architecture problems. So first, it is a problem of scalability. When a number of clients increases, the requirements for server power and channel bandwidth, they increase. And this is very, very easy to see when we have a server that provides you to download, for example, Ubuntu. This is Ubuntu. This is a Linux distributive. So we would like to download Ubuntu. If we have one client who wants to download it, it's not a problem. If we have 100 clients, it is not a big problem. If we have 1 million clients, it is a huge problem for the server, and this server would not be able to handle so much connections, and we would face a problem that a lot of clients, when they try to download from one server, they would not get the quality of the service that we want them to provide. And they would not be able to download with the speeds that we want them to use. So we need then to buy new servers, and we need to invest our money in this solution. And this is not the only way to solve this problem, and that's why a lot of developers and a lot of companies who are facing the same issue when they need to distribute huge amounts of data between their customers, they found another solution. They found solution of peer-to-peer systems, because if you have one big node that have Ubuntu, and now you have 10 other nodes that want to download Ubuntu, the first one downloads Ubuntu. Now we have 2 nodes who have Ubuntu to ask. So the second one can download this file from 2 nodes. The third one can download this file from 3 nodes. So that is about twice as fast as connecting to one computer. And the more nodes we have in our network, the faster we can download this distribution of Linux. So we do not need to buy more servers. We just need this file to be shared by as many users as we can. That improves the quality of this service, and that is, of course, a very, very nice way to deal with the scalability problem. The second client-server problem that we need to solve, it is dependence. The stable operation of all clients depends on the workload and operation of one server. And of course, in this case, we would like to improve the quality of the service by creating more servers. And peer-to-peer system, when each client is a server, allow us to deal with this problem. So what are the benefits of peer-to-peer system? First, in peer-to-peer system, there is no reliance on centralized services and resources. All services and resources are distributed in the network. Second, the system can survive a major change in the network structure. As I said, in the peer-to-peer system, everything is temporal. Our nodes can go in and go out. The lifetime of the node, we do not manage it. So when we create an algorithm to work in the peer-to-peer system, it should take into account that each of the nodes can be in or out in any time. And peer-to-peer system is very high scalable solution. So let's discuss the basic elements of peer-to-peer networks. So first, it is a peer. It is a peer-to-peer network node. And peer, it is a fundamental component of any peer-to-peer network. Each peer has his own unique identifier, so we can call this peer inside the network. Each peer belongs to one or more groups. Groups, they share their resources with each other. And each peer can interact with other nodes that we also call peers, both in their own and the other groups. We can highlight at least two types of peers. First, it is a simple peer that provides the end user with services of our peers in the network and provides the resources of the user's computer to other network members. So you can see here that when you connect to the peer-to-peer network, you become not only a client but also a server. And the second type of peer, it is router. Router provides a mechanism for interaction between peers that are separated from the global network by firewalls or NAT systems, and we would discuss this afterwards in the lecture. Also, we need to distinguish the group of peers, and peer group is a set of nodes formed to solve a common problem or achieve a common goal. They provide members of their group with services that are not available to nodes in other groups. So, for example, when we create a peer-to-peer network, we can distinguish several groups in this network. And one of the examples why we would like to have groups in the network, it is, for example, geographical location. So let's imagine that we have separate buildings, and these separate buildings, they are all connected to one big peer-to-peer network. But we would like the nodes, the peers inside each of the buildings, create their own group. For example, inside this group, they can chat. They can send direct messages to each other. And now you know that you can send direct messages to each of the nodes inside this group, but you would not be able to send messages to another group because it is a separate group. So now you have a group service that is available only for your group, but not available for nodes in other group. So peer groups can be divided by an app for which they are grouped together, by some security requirements, or by the need of information on the status of the group members. To organize the connection between the peers, we need a network transport. Network transport consists of three main elements. These are endpoints. These are sources and receivers of any data transmitted over the network. Pipes that are unidirectional asynchronous virtual communication channels connecting two or more endpoints. And messages. Messages are containers of information that is transmitted through the pipe from one end to another. That is very simple, and there is nothing special about this, but you need to understand that connection between the nodes is organized directly. And services. Services are functional features that can involve a separate site to fully work with the remote resources. So services can be provided by peer, or they can be provided by group. And such services, they are provided like file transfer, status information, computing, or any functional load that a node can perform in the peer-to-peer network. Each peer can have his functionality and his services. For example, file sharing, it is a service that can a peer provide. Once peer shuts down, its services become unavailable. Another type of services, it is group services. So this is a functionality provided by the group to its nodes. And services can be provided by multiple nodes in the group. And if one node in the group provides this functionality, then the functionality would be available to all of the group. So to organize the work of the peer-to-peer system, we need to establish a set of rules. And these set of rules is established in the form of protocols. Peer-to-peer network protocols, they provide a lot of facilities. They provide facility and possibility to search for peers in the network, get the list of services from a separate peer, get information about the status of the peer, using service on the separate peer, creation, merging, and leaving groups, and all the functionality that we described before, it should be implemented using peer-to-peer protocols. So in our next part, we would discuss main protocols for searching of the resources in the peer-to-peer network. That is one of the main distinguishes between the peer-to-peer systems that we can highlight. And also we would discuss the routing protocols using the routing peers. Our next topic about peer-to-peer network algorithms. So let's start from the most well-known and understandable. It is centralized index algorithm. So how it works? When we have a peer-to-peer network with a centralized index and a new node appears in the network, first that this node is doing, it sends the list of the resources that are available on this node to this centralized index server. And they do not send all their resources to the server, no, because that would be a huge amount of information. They send only the metadata, only the description of what files do they have. And when some other node in the network where to get some resources, it sends the request to the centralized index. Okay, I would like resources this and this and this. How can I find them? And the index would give him back the address of the resources that he or it required. One of the examples of this approach, it is Skype. Before the Skype was acquired by Microsoft, it was organized as a peer-to-peer platform. So the Skype was organized the following way. It was peer-to-peer system, and all the voice calls and web conference calls, they were organized by peer-to-peer connection. So users do not send their data to the direct server, they are connected directly to each other. But when you launch Skype, you send your request to the centralized server and you ask it to provide you the list of the addresses of your contacts. So you send your direct request to the site and tell him, please tell me where my contacts are located. Are some of them online or not? And this centralized site would give you back the list of all your contacts with the IP addresses, how to connect to them. So then you can, after you receive this information, directly connect to the computers that you would like to interact with. So advantage of there are huge advantages of this approach. First, centralized index allow you to provide reliable and fast search in the network, because all the information about resources is available on this centralized index. And metadata size is not very big. For a system such as Skype, it would be several terabytes of data, but it is not huge amount of data. It is very reasonable amount, because you need only information about the nodes, very, very small amount of information. But there are some disadvantages of this approach. First, here I wrote small scalability. It is not small scalability, of course, because the metadata information is not very big. Scalability, you need to scale the server somehow, but it is not a huge problem. The biggest problem is the dependence on the central server. Let's imagine that this central server is broken. You cannot connect to the central server. How do you get the information about the nodes in the network? There is no other way. So that is why when the Microsoft they acquired Skype and they started to rewrite their protocols, and in one time they broke the central server, and it was several days when the Skype was unstable. And if you had a client that already connected and know the IP addresses of their address book, then you could call your peers because the calls are direct. But if you did not know the information about the IP address of some person, without the central index, you would not be able to get it. So this is a disadvantage of centralized index approach. Second approach is opposite of the centralized index. This approach has named broadcast queries. So broadcast query approach means that if you want to find something, you do not call some centralized index. You can see here that there is no server whatsoever. There are only peers in this network. So how do you search in this network? You ask for the resource. You ask your neighbors about the resource. So if you want to search, you ask your neighbors, do you have this resource? And your neighbor says, no, I don't. I don't know what you're talking about, but I would ask my neighbors. So we see that these peer would ask his neighbors that he has information about, and he sends his request here, and one of them have the resource that this computer asked. So it would organize the direct connection with the computer so they can share this resource. After, it also goes further and transmits the request to its own peers. So we see that first layer, it is just neighbors of the first node. The second layer is the neighbors of the neighbors. Third layer is neighbors of the neighbors of the neighbors. And we have this huge amount of computers that is involved in the query propagation. So we can see in this network, we found all the nodes that have the resource, and they are connected to the node that sent the request. Example of the implementation, the first implementation of this approach was implemented in the first version of Gnutella network. Now they have some specific version, more reliable version of this approach, because this approach have huge disadvantages. First of all, high network bandwidth is required. You can imagine if a node in average have about 1,000 peers that it knows about. So a node in average have about 1,000 peers in his first circle, and he would send 1,000 requests to his first circle of peers. And the third circle of peers, each of them also knows about 1,000 peers. So they would search and send this request to another 1,000 for each of the elements. So that would evolve already million requests on the second layer. Third layer, it would be 1,000 millions. It's a billion of requests. So these would hijack the network with huge amounts of requests that are going and going and going. So in standard protocols for broadcast queries, the query have a lifetime. So we say, okay, you can jump 3 times or 4 times or 5 times, and after you jump 5 times, you would stop propagating the request. Because if the query would jump and jump and jump forever, the network would be filled with the query requests, and it would not be able to organize good file transfer or resource sharing. Second, reachability is not guaranteed because we have a lifetime of the request, and we say, okay, you jump 3 or 4 times, and after this you do not jump any further. That means that if we have no resources in our area of first like 5 jumps, then we would not find this resource whatsoever, even if it is available in the network. So that is a second disadvantage of broadcast query. To solve the issue of working without the centralized index from one side and huge disadvantages of the broadcast queries from the other side, a new way to organize the search in the peer-to-peer networks was developed. This way is called key-based routing, and right now it is one of the most interesting and promising ways to organize resources discoverability in the peer-to-peer networks without centralized index. So let's take a look about how it is organized. Each peer in the network, in the peer-to-peer network, first should be allocated with a random key ID. So in this network, you can see that we have some peers, and each of them has its own ID. This peer is 0459. This is 0009. Okay, we assigned each peer with an ID. And when a new peer arrives in the network, it automatically assigned with a new ID. So we have a new peer here, and this peer have an ID 7008. Great. We have network, we have peers, and these peers have IDs. Next, when we have a new resource in the network, we also assign an ID to this resource. And the ID of this new resource is calculated from the same range as the peer's ID. So here we see that on our new peer 7008, we have a file. And this file or document or resource whatsoever, it has the ID 0110. And you can see that just looking on this ID, you cannot distinguish this ID from the IDs of the nodes inside the network. That is to make this algorithm work, you create the ID of the resource in the same range as the IDs of the nodes in the network. So what you do next, it is key-based routing. You compare the ID of the resource that you created with the ID of the node that it is located right now, and with IDs of the nodes that are neighbors to the peer that we are working with right now. So here we're comparing 0110 with 7118 and 0459. What is the nearest ID to the 0110? Is it 71008 or 0459? Of course, this is nearer to this ID than this. So what we do with this resource, we copy a link to this resource to this node. Second stage, we compare this identifier with, just a second, we compare this identifier of the resource with the neighbors of this machine, 5053 and 0009. So we comparing and we see that this identifier is closer to this resource. So we copy a link to this machine. Bam. Repeat. Bam. So now our resource 0110 is located on the machine with the identifier that is closest to the ID of the resource in the network. And now we know that the ID of the machine 0040 is the closest comparing to its neighbors to this file. Why do we do this? Why do we copy links to these files through the network? So the network now have a lot of separate copies or links to these files. We do this to organize the search, because the search is working very like the same. Here we have a machine 5023, and this machine would like to find the file 0110. So it sends, we know the identifier of the file that we want to find, and we know the identifiers of the machines that are our neighbors. So where do we send this request to find the file? We send it to the machine with the closest identifier to the file that we try to search. So now we would send this request to the machine 0340. It goes here. And this machine would transfer it to the machine 0040 because it knows that the identifier of this machine is the closest one. And now we found our file. So in the key-based routing algorithm, we use the entirety of our network as a search engine. That is mind-blowing. That is so cool, and it is so efficient. So right now, a lot of peer-to-peer networks implemented this way to organize search for resources inside their systems. Examples of these, the implementation of this key-based routing, it is a freenet or DHT over net in the BitTorrent. Advantages of this approach: first of all, comparing to the query broadcasting, you do not need to send your request to everyone in your neighborhood. You send your request only to one machine, one-to-one, that has the closest ID. So because you send it only to one machine, you do not hijack your network with the queries. You do not have this exponential growth of the queries between the clients, between the peers. The disadvantage of this approach is that you cannot search the resource by the contents of the document. If you do not have the identifier, you cannot organize the search whatsoever. It is impossible. This is a huge disadvantage, but then you need to find some other way to get the ID of the file that you would like to find in the network. And one last thing, one last algorithm that I wanted to cover today, it is bypassing firewalls and NAT in the network. So now we are working with mostly with IP version 4, not IP version 6, and the IP protocol version 4, it lacks the amount of IP addresses. So private networks mostly are located behind the net or behind the firewall, like this. So if we have a firewall that separates our LAN and our client from the internet, how would we pass our requests from the internet to the client? The firewall would block these requests. The only way to organize the bypassing of firewalls and NAT is by initiation of the connection by the node inside the network. If the node sends the request to the router node in the network, then the router node can send back all the information that the client asked as a response to this request. So here we see that some remote node wanted to send some information to our node inside the LAN. But it cannot send this directly because the firewall would block this direct connection. Instead, it sends the information to the router node, and the router node stores the request. When the node in the LAN is ready, it would send the request to this router node, and the firewall would not block it because it is the connection that was initiated from the inside of the network. So, and this router node would give back the information, the request that this remote server sent. So these nodes that help to organize connection inside the network, they are called routers of the peer-to-peer network.